Okay, everyone, here we are in our final answer section for chapter 10. We are going to train our support vector machine on Iris, the Iris dataset. We are going to use nomenclature from our statistics class of x and y, dependent and independent variables, to talk about our mostly to talk about the data being x and the target, the value that we want it to be y. We are going to do some creating some training and test data sets and doing some list manipulations. We're going to use a linear kernel for our support vector machine. We're going to have to build our model, create an object that has all the required parameters in order to receive training information and the test and the training labels, so it can make a bunch of different, it can like correct itself if it's wrong, for instance. And then we're going to evaluate the trained model on some data that we put aside to see how good it is with data it's never seen before. Okay, and then we're going to create some sort of accuracy measurement, a simple one. There are more complicated ones, and you can actually, there are some functions in Scikit that will help you build them automatically too. So with that in mind, let's just do the simple way so you at least understand the process and how all this is going. So first one here is to import our support vector machine class, our list of functions within it. And then we have our Iris data set here that we're going to load in. So first we create our Iris object. We set our data, which is the iris, which is the flower, petal, and sepal lengths and widths, as one object. And what I did for my training and testing subsetting, guys, is that I just took the first chunk of them and left about 25 out for testing. This is not the best way to do it. And why is that? Because the last chunk only has one flower type in it. It has like just the one set of the class 2 stuff only, basically. So what you should be really doing is randomizing this in some way and then selecting out the x's and y's. That's the proper way to do this. But I didn't specifically ask you for that because I wanted to just more show the process as opposed to all the specific tweaks that you need to do in order for this model to be like super accurate and optimized and proper. I just want to I'm trying to show you like how you build these things in the first place and the phases that go into them in a very simple way. So I created my x and y here. The targets are the class types as an integer, and then my subset is the remaining data, and that's all that is here. I then create my model object by using the SVM, support vector computation, I think that's what the C means, and telling it what kernel I want. There are a bunch of other parameters that you can put in here that will impact how it learns. And this is called parameter tuning and parameter estimation. And that's a very interesting process that is an advanced data science and machine learning concept that you'll probably learn about if you continue learning about machine learning. Then we fit this data. So we put the training data and the training labels into our model, and then we get it to evaluate its accuracy within itself. So like it'll then use its own data to kind of tweak itself to see if it's right or wrong. Then what we then do is, now that the model has been trained, we want to predict the label of new data. That's one of the appeals of machine learning. So we give it our subset of data, our test data, which is just our x information. We just give it the dimensions, and it's going to tell us if it'll try and guess what the label is, 0, 1, or 2. Okay, and that creates a list of predicted labels. Which we can then compare to our y-test object, which is the actual labels. All right. So then how I do the evaluation is, this is a simple one. I just create an object called test score, which is just an integer, and then I compare the predicted list to the actual list. And I use enumerate here because I want to get the index position to check my other list object. So I go for the data itself that is in our predicted model, as well as the index number here. This is these two objects. I then see if the predicted number is equal to the actual number, which I'm extracting using the index from enumerate in the y-test list. And then if it does, I increase the test score. Okay, so I increase this number, saying, yep, it got it right, bing, and go through that. I then have a test score object, which should have all of the correct guesses as this number. And then all I do is print the accuracy. How I get the accuracy from this analysis is I divide the amount it got right by how many there actually were, just like you would for your own tests if you were, in class or something. So I do that by getting test score divided by the length of y-test, which is, I could even do the length of predicted. It doesn't really matter. Just the length of either of these lists, how many elements are in there. And that will give us our accuracy. So let me run that. And the accuracy is 88% with this information. So that's kind of cool. And there are ways to get this much, much higher in terms of accuracy by doing a lot more refined analysis. Okay, guys, that's basically the answer for Chapter 10. Thank you very much for this class and getting all the way through. Congratulations. I hope you have a more detailed understanding of what data science is, how to do some Python coding, and places that you can go to or where you can learn skills without having to, practical skills basically. So you've learned the kind of the fundamentals of a lot of things without all of the detail in them. It's very high level, but also specific in some ways too. You just train to support vector machine, you know what I mean? So thank you very much, and have a great day.